So let's get started. Today my topic is regarding the topology-aware service routing for Kubernetes. And the name is quite abstract. For this new feature, those who are familiar with Istio may know that there is a local routing, and this is more like with the support of native Kubernetes, like zone local or region local, any kinds of a local you defined, or even other kinds of you defined. And first, a brief self-introduction. My name is Du Jun. I work for the upstream in the community and maintainer for Kubernetes Istio and Kubernetes, and in charge of CNI bandwidth and other Kubernetes SIG network. And I already published 2 books, and the 3 is about to come in the next month. So we will begin our session today, mainly from 4 aspects. So the whole Kubernetes, the design of the whole compatibility system, and the compatibility of the network, why are we doing that, and the specific need, as well as the actual design and the demand. For Kubernetes, we say that as the design for its compatibility, there are 3 main parts. And in 2016, I worked with Huawei in the community to promote this coordination compatibility. I think you must all know about that. And there is also a concept saying that for your pod and node is compatible with each other. For example, like pod A and pod B, they are also compatible with each other. And coincidentally, we have a local node. What does it mean? It means that I have this pod which need a storage device locally. Although that the PVC is combined with my node, but after the coordination, I found out that there's no local stores that I need. We need to delay for this kind of connection. And the third one, you will find out that, for example, like for Huawei, we need 2 zones, AAZ and BAZ. We can use AAZ and BAZ. And for the user end at AAZ, I hope that the visits can be the same as all the ANs, because the cross-region will cost a lot. And so we are thinking whether we can have a local and pond this new feature. And to be more specific, it's a topology service routine. 1 year ago, we already finished the design, but we didn't find the proper partner to begin the development together. So now we have already updated the version to 1.6. In Kubernetes, how to express the compatibility? It can be compatible with a certain main engine, to a zone, to a framework. So all those subjects and targets, like a label, a map, or value. using the topology concept to express compatibility, that we have this relationship in a certain zone or a certain framework, and vice versa. And how to express this is via label to express any subjects or targets. And also, we know long ago in the community that the coordination of compatibility, how to design a new one, we can maybe learn from that, get some inspiration, and go back what is coordination. The question we would like to answer is which machine that I would like to run my code on. And on the left, there are node affinity in the coordination process, how to write all those code. The node affinity, it is quite a similar expression and supports 4 kinds of expressions. So altogether 4 expressions. And you will realize that there are also 2 kinds of compatibility. One is the hard one, and other one is soft one. One is the in those red with underline, and the soft one is the preferred. So there are all kinds of other requirements that you need to meet. And also there are a lot of, it can be called node 1 in our example, with the labels on it. And with the AZ and or AZ2, they can be coordinated, and they also meet all those requirements. With the label of host 1, it is preferred with the weight of 100, which means that in terms of coordination, it uses initial still using the labels to describe topology and to request to describe the hard ones, the hard requests, and soft ones. And in the network, we can also learn from this kind of method. And in terms of the network topology, when we visit a server, we need to find the nearest port. On the left is the working function of the service. As you all know, it's via the label, and to choose the port on the background. For the service and endpoint, there are 2 in terms of Kubernetes. Kubernetes and CoreDNS are also connected with pod and server. For the headless one, using stable set, we use the headless service. It's change name and reject to the list at the backstage. So if you support that one, we need to do in the 2 parts, to develop in the 2 parts. One is KubeProxy and one is DS. So this picture illustrates the service, the internal routine of the service of Kubernetes. Altogether 3 connecting targets, service pod and endpoints, all in etcd, and the endpoint controller will read pod and service pod to produce the endpoint's subject and to run kube-proxy at each point Then targeting. As for the user end, service is a virtual IP. It's called virtual service. For endpoint, it's a real server. It's the actual backend. And also for kube-proxy, it supports IPT and IPVS mode to write the routing principles. And for LES, it's directly create the real match. And that is the common Kubernetes. With topology, how to make changes. For endpoint, we do not need to make changes, only the kube-proxy. And next we will briefly go through the needs. For those who are familiar with this part, external traffic policy can be defined. You can choose to be local or local means that you only transfer the traffic to the same pod at the same node. Same nodes at the kube-proxy. And with this function, why we still need to invent this new concept? Because it only supports the cost class local, and zone local, region local. Therefore, we need a common one that can be shared among them. If we can limit that to point to a specific one, then we can do the matching support in terms of a kube-proxy. But due to the all kinds of needs, we need to have this kind of invention to limit the behavior, and also from the perspective of security. For the cross machine, there are some sensitive data. Like on AW, there is a proxy that is not allowed to cross the node due to security issue perspective. As for every node, there is a even set to deploy one. Another is the cross June that costs a lot. And also due to latency issue. So we decided that we use label to describe the topology field using the mechanism of Kubernetes. And as we discussed before, we have the hard compatibility and soft compatibility. You need to support both. And for the hard one, it's just making the request directly. Otherwise, you will receive a connection refused. And for the soft one, it's that can be also used. So if it is a soft compatibility, which can meet the two pods, then which is preferred? That is under the customer's definition. You can label the weight on it. Maybe with a certain label, it has 1 weight or 100 weight or 10 to see the weight. And for example, like kube-proxy, whether it's IPVS or IP tables, they both support WRR. But even you have a score, they can also support those weights technically. Talking about all the strategies, who will do the configuration? For external traffic policy is the user, and for SDO and network policy is the administrator. Using the set-way control with the name list, and whichever the pods are matched, there will be a constraint on them. And using the set-way control, and there's another way. So directly written on the server to add other strategy directly. And here are the questions, and here is the API design. It's the defined API design. It's written on the service spiker. It's not a side-way control. It's a direct one to constrain the specific service. And the API is quite simple, adding only one feature. It's a string called topology keys. Topology keys. And for the strings, we have 1, 2, 3. And the smaller it is, the constraint has the higher preference. It means that they have this kind of a preferred priority. For example, there are two elements in the string, and one is a host, another is root. It means at first, to meet the local host, if it doesn't match, then goes to Zoom local. Then this is this kind of soft priority.
If all the elements or components cannot be matched, what should we do? Then none of that has been fulfilled in terms of requirements. Then we'll have some, I would say, hard conditions in place. If the host is empty, then it can be compatible with the backends. That is to say, then we don't have any restraints. As long as we can find out fulfilling requirements for the backend, then it will be figured out. It's not just like scheduling or dispatching. It is placed like prefer or required something, and then wait for some other things. Of course, we can do some simplified design, and later if we have to put a weight on that based on our user experience, then we can add that to it. It will be simple. It will be a weight host, and it can match to each one of the P host, and therefore the component or element of the first host, that is the weighted host, that's actually the first match. Yes, that's it. And it's not even alpha, it's experimental. Why is that? Let's take a look at the first workflow. That's how it looks like. First of all, kube-proxy, besides service in pod, it will have access to all kinds of services and nodes, because we've got many nodes there. Many people are less worried about that, and it will produce a large traffic built based on our own experiment data, as well as the ideas from the professionals working in this area in the community. But it does not really depend on the traffic load. Rather, it depends on the frequency of changes of it. For example, for a long period of time, and it's empty there, then it will not lead to a large cost for the service end. Then, if we have all these service nodes, and when the label changes, the data will be transmitted according to our order, then the changes are not that frequent, therefore the traffic is not that much. But if the heartbeat or the node is always subject to change, then it will lead to a large traffic, of course. And as for node topology range, it's actually expressed by the node cable. Then how can we express topology, and it's actually identical to node topology. For example, for nobles in ACE, then the pod is in the same as well. Then how does the workflow look like? For topology, it has its own node name, and we have all the nodes. Then at the localized cache, it has stored all the states of the node, and that can be the key to search the node and get the node objective. And then we just get the layers further. Then we'll be able to know the topology range. And as for the pod, we'll be able to know whether this pod and the other pod is in the same range. If so, then the traffic can be directed to it, or else we wouldn't be able to divert the traffic to it. That's how it is. To summarize a little bit, for project service, we do need to return to the backend pod in the same topology range. If there's one, then just return to that. But if there are two, then we just do that in a run and robby manner. That is to say, do that randomly. For Kubernetes, it is how it is. For headless service, headless service, it can be implemented or actualized. For DNS, how it's going to be used? This one. First of all, the headless service, the domain name as well as the IP list at the back end will be matched, or for example, a service request has sent, and all the IP list at the back end will be projected as well as matched. But in topology, how we're going to do that? For the IP list in the same topology domain will be, or range will be returned. For example, originally there are only 5, but after we check there are only 3 of them in the same topology range, then only 3 will be returned. It's complicated, right? But before we enter into beta, we don't need to realize all of this. For alpha, we just need to achieve the preliminary goals. By the way, you just feel like the design is not that reliable because it's complicated, and then why you have to access all the nodes? As a matter of fact, in community or for community's work, we need to pay attention to the current characteristics, but also other characteristics that can be related to the community in the future. For example, for us, for me, I need to watch an object, and usually the data about this object will be all returned to you. Then, what if I only need this node label, and when that changes, you can push that to me. But as for other data, I don't need that. And for the community, it has been wanting to do this for a long period of time, but it actually covers a lot of area, and we haven't really seen it settle. Then why do we need to make full use of the kube to access all the nodes? For me, if I want to access the node and it is very useful, then we do need to resolve this problem. When you just introduce the problem in the system, you need to resolve it eventually. Then during this entire process, you will be able to bring everything forward. And in the community, which is called scalability, and the group leader, community leader, is actually Polish, and he just rejects everything that might seriously affect the Kubernetes, and that's how his take on this matter. And for this matter, this is not just about affection, rather it can also be taken as a very important characteristic. And they do need to resolve this problem. Then how to do that? Then for Field Master Watch, this issue will have to be introduced and resolved. And if you watch, you should know that we can designate, for example, for not with a specific label, all of this will be returned. We can't support that, but there's no way for you to designate the attributes or the characteristics be returned to us. If you do this kind of work, you might find that the Kubernetes or K8 will be enriched to another level. Why is that? First of all, we find that it is subject to the watch list, and there's no way for K8 to watch list. And when they do the watch node, they can actually do a lot of things. And we can actually bring the K8 into the next level. And if we will be able to develop the alpha trait, and after we move into beta, then the API will, of course, be changed, and then we can see the CRD of pod locate. For this CRD, of course, it can be used by Coupa, then it's not watch node in that way. Of course, it can be used by Kubernetes or CodeDS. Then what's inside there? I mean, what is stored there? The node's name, and also the pod IP running on it, as well as the matching relations between the two, why this kind of information will be stored there. If you don't watch node, then you have to know what exactly are the IP address of the applications running on pod as well as label. If there's a field master, then we can actually store this in the first place in an opjoiner. Then it can deliver benefit. Because the heartbeat of the node can be changed on every 10 minutes, and this way we'll be able to do the core DS because it has to track the port's IP address. Basically, that's my speech. Do you have any questions? Sorry, the audience are not using the microphone to raise the question. Some of the pod, they don't have the labels. Again, no microphone is used. I haven't considered your question. I'm sorry. You mean you produce it by yourself? If you use under pod control, of course, things like you've just mentioned will be automatically produced. For all those questions, I haven't really taken into consideration so far. No microphone is used. For core DS, it's simple. For 3 IP addresses, you just write them into it. Let's just forget about WR, only focus on RR. We can do that, of course. And you just mentioned WR. Of course, for the alpha version of that, it's not compatible with this function. If you take a look at API, we just define a host, but for the purported keys priority has not been detailedly described. 问题给个话筒可不可以？现在给呢？对，跟这相关的，对，对，是的，是的，现在是。然后就顺带说一下，就是如果说我们不 watch node 也可以。If we don't watch node, it's okay. But we can have something else to do here. In the first place, we say CRD is first class citizen. If you just watch the CRD, you'll find that the CRD's position will be improved in K8 world. You can find that there's no major component and there's no dominant component to watch the CRD, and there's no way for you to prove I'm wrong. No microphone is used. It's a couple of months ago. And for that characteristic is actually developed by our team member. We always talk about CRD is actually a first-class citizen. For CSR controller, when I watch this, we're not very willing to accept that. If there's no more questions, shall we call it the end of that? Thank you again. Thank you so much.